It's 802. I think we can start. Okay, no problem, Dr. Asma. We have this in record. So hopefully, if the computer do not crash anything, upload to the recording to the YouTube, and I'll send the link to everyone. Okay, so today's sharing is about building. Is a basic guide on building the data set for analysis in SPSS. So we're going to look at the basic interface of the SPSS, and then we're going to look at the basic of the data entry into the SPSS. And finally, we're just going to do a quick check for the data distribution. So this is important for you to decide whether to use a parametric or non-parametric test. So an example of parametric test is student t-test. And example, so for example, you want to compare a group of, let's say you have a group of patient versus control. You want to look at the difference of, let's say, their height. So you put in the you want to compare their mean basically. So if it's normally distributed, you're going to use a parametric version of the test, which is student's t-test. But if you check and the data distribution is skewed, so you may want to use non-parametric version of the student's t-test, which we call as Mann-Whitney U-test. So the point number three, the step number three is very important even before you start your analysis. So first we look at the interface. So this is the view of the main screen of SPSS. I think most of you know this as well, but we're going to go through very briefly, and we're going to do like, I'm going to open my SPSS and we'll do together later on. So this is the main data view. So this is where your main main data will live. So the next step, if you look at down here, you have a variable view. This is where you want to edit or admin or govern your all your parameters. So basically, this is where you will define your parameters, whether it's a numeric or a string, whether it's ordinal or is it a scale. So we're going to look at that later on. So another window that is very important is, of course, the output window, which is where your calculation, your analysis will be displayed. Yeah, I'm sure all of you knows about this, but we're going to just go through the basics. So, of course, again, this is the main page. If you want to make a new data set, then you're going to go to File, New Data, and open a blank spreadsheet and so on. I think you guys will know this, so you're going to skip. So for data entry, when you want to, before you want to start your data entry, you have to know the nature of your data, whether it's a numeric data, whether it's a string data, or whether it's a date, and so on. So for example, if you have something like height, blood pressure, for example, systolic, diastolic, probably weight as well, or you have, like, for example, in cardiology, you have augmentation index and so on. So those are the numerical tests, parameters. So if you have something like, let's say you want to list down all the comorbidities of that, of what the participant had. So it's going to be a list of comorbidities, then it should be regarded as string. It can also be like alphanumeric things, for example, like US postcode, for example. So that kind of things. So it will include any open-ended question as well. For example, if you have a questionnaire that asks like opinion or something like that. So if you still want to put them into SPSS, you want to analyze later on in terms of descriptive analysis, then you can do that, but you have to define that as a string parameters. So there's also a few more other parameters, but these are not so widely used, especially in clinical. setting. But just to note a few, that you may want to define that parameters as a date, so that you can probably calculate the start and end date later on in SPSS. Or if you want to record like a really a currency, for example, then you can do so. But it's not really important. As long as you have defined them either numeric or string, then it would be okay for you to do the downstream analysis. So after we have defined it as a numerical data, so you have to know whether it's a continuous variable, whether it's a count, whether it's a nominal or ordinal parameters. So an example of continuous variable is it's just a truly a number in range. For example, height, weight, blood pressure, and so on. So um, at the end of on the variable page, at the end of the column, you have to define that as scale. We will look onto this later on. So you may also have a count. For example, how many times the patient has been admitted, for example. So those are the counts. So you have to define that as scale as well. So if it's a count parameters. For nominal parameters is usually defined as the sort of you want to group the participant. For example, you want to group them as male and female. So in this example, we coded 1 as male and 2 as female. And you have to define this as nominal. So nominal basically is when there's no weightage basically between the group that you have defined. But for example, if you have in a situation where you have a disease, for example, that a male is more prominent or have higher risk than female, for example, then you may want to consider that to put as ordinal as well. So nominal ordinal will depend on the weightage basically. So again, for the ordinal, things like, for example, Likert scale, whether it's good, better, best, you want to put them as 1, 2, 3, as with increasing importance. So something like that. So you have to set that as ordinal at the end of the column on the variable page that I showed just now. So my suggestion for the nominal is that whenever you want to do, even if you plan or you don't know yet, but you may want to do some logistic regression analysis later on. Most importantly, if you want to do binary logistic regression, then you may want to code them 0 and 1 rather than 1 and 2. This is very important because when you want to do a downstream binary logistic regression, the binary regression won't recognize 1 and 2, but they will only check for 0 and 1 in the grouping. This is a bit more hard to tell in words, but later on when you want to do the binary logistic regression, then we can see that, we can explore that. So we go for the data entry part of the session. Basically, if you go to the variable view, you want to name the parameters in this column. Basically, you can put in anything as long as should not have any symbol or space. So you can put in some short forms as well. But then you can use this label column to really write what is the parameter is all about. So this will help in a way if you want to, after you have your data entry, then you want to ask somebody for help to check your data and so on. So because this might be just a short form, then you may want to put in detail of what is the nature of the parameter in the label column. So that will be easier for everyone later on, or even for yourself if you have created this data set like years ago, then if you come back and open again, you may be able to understand what is the data, what is the parameters all about. So it's important for you to use this if you use any short forms. So you have the type here, as I said just now, you have to define whether it's a numerical or string. So of course you have more, but this is the two main type that we usually use. Width is basically the width of the data that you want to put. Let's say, for example, you want to code, like for this one is school class. So you want to set as first year as 1, second year as 2, third year as 3, fourth year as 4. So these are, it depends on the nature of the study. So we can just treat it as nominal for now. So as this is a nominal parameter, and it's 1, 2, 3, and 4 is a round number. So you don't have any decimal, and the width is 8, is very generous. You can just put 1 here. So it'll just record like 1 digit. So whenever you put the width 1 and you have a number of 12, then that 2 will not be shown. So that is very important. So you can just set it as default as 8. So usually you won't reach the 8 digits for the group. Okay, so let's say we do this for, we just carry on with this example. So next is when you go to the data view tab, you can see that probably we'll skip this and we'll go to the SPS later on for better understanding. So now if you go to the data view, you can see that you can start to to do your data entry. Yeah, so this is an example. So you can put in, so like just now, 2 is the second year, 1 is the first year, and so on. So that's all for data entry. It's very basic one, but we're gonna go hands-on in the SPSS later on. So just want to show like quickly about how to do a normality check. As I said earlier, normality check is very important for you to decide whether you want to use a parametric test or non-parametric test. So how to do this is once you, so this example of my parameter, we're gonna play with this parameter later on. Sorry, data set data later on. So you go to the analyze tab, go to descriptive statistic, and then go to explore. And then you're going to have this pop-up window. Then you're going to select which parameter that you want to check for the normality. So here, dependent list is the parameter that you want. And let's say you have a group. Let's say your study involve 2 groups, for example, patient versus control. Then you can put in the group here. Or if it's a cohort study, a single cohort study, then you can leave this group as blank. So it will just check the these parameters that you input and check the normality. So don't press OK yet. You have to press the plots and then check this normality plots with tests. And then press continue and then press OK. Then you're going to find in the output window this table. So it is the most important table for you to check. There's actually, so for SPSS, they will give an output of 2 tests, Kolmogorov, Smirnov, and Shapiro-Wilk. Both is the same, I would say, but more people tends to use Shapiro-Wilk because it is arguably more powerful of the two. So you may want, I think we just stick with Shapiro-Wilk for everyone. So what you can get from here is, for example, so I input of 3 parameters here: AX percentage, which is the augmentation index, age, and height. So you can see here is a significant value for these two, but not for the height. So what it means is actually if the value is less than 0.05, it indicates that these parameters are skewed or not normal. So if you want to do anything downstream, you have to choose the non-parametric version. If you want to do a comparison of the mean, or then you're going to use Mann-Whitney U-test. If you want to use a correlation test, for example, you're going to use Spearman rather than Pearson. So that will be later on. So for height, you can see that it's a normally distributed parameters. So we can use the normal version of the parametric version of the test. So I think that's all. We're gonna go to now. We're gonna go to SPSS. Okay. So this is a data set that I've been working in I think I created this data set in 2016 or 2017, so it was a long time ago, but it was an example for today's session. So basically, this study is about um, survivors of survivors of childhood cancer. We want to look at the augmentation index or the arterial stiffness, basically, of the cancer survivors versus the control, whether the survivors have worse uh, augmentation index or arterial stiffness compared to the control. So that is the basic of the study. But basically here you want to see the okay, let's go to variable view. So you have to define your parameters here. Then you have to define the type here, string, for example, the ID or normal range. So for this case, because I want to look at the AIX percentage, is the augmentation index. I want to define what is um, the normal value for this person. So the normal value is 6 to 29. So it's just a reference for me. So it's not anything that we will analyze later on. So this will be defined as string parameters. So as you can see here, it's a string parameters. So the width, because um, it's slightly longer, slightly wider in terms of the width. So you want to put in like slightly bigger. But most of the time, if you are using SPSS 15 and above, it will be automatically defined. So you are okay there. Unless you want to copy paste after you define, let's say for example 8, and then you copy something with the width of 10, you pasted it onto SPSS, then you may lose the last 2 digits. So yeah, just bear that in mind. Um, so of course decimal again is not important here. So there's no decimal because it's a just a parameter. So for example here, this is the main parameter that I want to look at. It's a augmentation index. So I decided to have um, one decimal point. So you can put it 1. Let's say you change this to 0, then you no longer have the decimal. It's a very straightforward thing. So we're gonna use this again. So values is basically because this is a continuous parameter, so it's a numeric. So you want to change the measure to scale. This is very important because most of the time, if you don't change this, if you retain this as normal, as the default one, I'm not sure what is the default one. I think the scale is the default one. If you have something like group that retain as scale, then if you want to do something like chi-square, then you would not be able to do the chi-square because it will come up with some sort of error because you haven't defined this properly, which is you should make it as a nominal. So, so I would say when you want to define the parameters, the most important, few of the most important column is basically the type. You have to define it properly. And the measure. These two must be accurate. You must define properly. So values is something that is, if you have, let's go to the data view again. So I have this percentage. So if you see this first entry, this person has has a value of 64, but the normal range for this person, it should be 6 to 29. So this person has some, it's not normal. Basically, there's augmentation. Basically, there's a arterial stiffness happening. So you want to denote as 1. So whereas for people, let's say for the entry number 3, it's within the normal range that we expected for this patient. So I coded it as 0. Basically, it's a normal. So you want to define your AIX status. In this case, I put it as AIX status. I didn't put in any label because it's just for me, but it's good practice for you to label what you have here. But you can see here, you can define it as 0 as the normal, 1 as abnormal. So again, as I mentioned, whenever you have a nominal scale, you want to define the abnormal or the patient or the affected group as the number 1, and then the comparator or the healthy control or baseline as 0, so that downstream when you want to do a logistic regression, you can straight away do without any recoding. Of course, if you currently you have a data set that already coded as 1 and 2, it's fine. You can recode later on, but just to save your time, then you can straight away code this way. Yeah. So missing is basically you want to define whether if you have empty you have missing value. For example, this one. So this a heart rate for the entry number 12. We didn't manage to get the heart rate for this uh, page, this control. So basically, it will be defined as dot. So yeah, it's just a definition. If you want to make it as some statistician, a pure statistician would like to code it as 99999 to denote as missing value, but it's up to you. I just prefer to just make it like empty. I know it's a missing value. It's this is just a preference for you. But yeah, that's about it, I think, for the data entry bit. Um, yeah, so if we just explore a bit, so for example, gender, um, initially, because this one I copied from Excel, so we put it as female, male, female, male. So you can recode it as 0 and 1, as I said. So if you have something like this, if you want to, it probably like before this, you didn't expect to use SPSS to do your analysis, but now you have something here. Of course, you can do it manually 0, 1, 0, 1, 0, 1. You could manually, but you can also use um, the transform function and then recode in the, it's either same variable or different variable, it doesn't really matter. But let's say same variable, so you can choose this gender, then you can define this as F, you want to recode as 0, for example, and then the male, you want to recode as 1, then you press OK, then all your uh, gender will be recoded as 0 and 1. So after you have recoded this way, you have to change this gender, this gender parameter, the value you have to define. So just now we put 0 as female and 1 as male. Okay. So after you have defined this, then you won't be confused later on. Plus, after you put in the value, after you recode the value, you can use this icon. When you click this, it will change to male or female, so you can read it like easier. So I've coded it, things that you have coded correctly, then you can see the alternates like that. So basically, this is also important. Once you have coded your data, you have to change the value. If not, you're gonna be confused later on. You, especially if you don't standardize them as 1 0 to 0 1, and some you have 1 0 1, some you have 1 2, and some parameters you have 1 2 3 4. So it's gonna be a bit confusing later on. So straight away you have to define this from the very beginning before you put in your data. Um, yeah, that's my advice. And later on, if you want to pass on to somebody for statistic help, then it will be a lot easier for that person as well to understand your data by looking at these value labels. So I think that's about it for data entry. It's quite straightforward. I think most of you knows most of these things. So the next thing we can try to do the normality test. So basically go to descriptive and then explore. So like just now I said, if you have a group, like for me, I have a group, I can put in group here, and then the distribution check will be break into two, survivors and controls in this case, but we don't have to do that. So for example, just take this. Let just for fun, we just now because we have the result, we add another one. For example, let's add the heart rate, for example. So you have to press the plots, then make sure this is checked so that the SPSS knows that you want to check for normality. Then it should be okay. Everything else you can retain as a default option. Then up to you for this one. You just put both is fine. It will show you both plots and and the tables. So if you can see, this is the output. So here you can see the summary. Basically, I have 151 data entry and one missing for some reason. So you have the report here as normal. You have the mean, median, and so on. So for example, so here this is the table that you want to focus on. Let's see the Shapiro week. Whenever the significant value is less than 0.05, it denotes that the parameter is skewed. So you would want to report them as a non-parametric parameters. So for example, you want to report the age. Now that the age is skewed, you may want to report them rather than mean. With mean, yeah, mean. You may want to report them as median instead. So as you know, if the data is skewed, then it's more accurate to report the median rather than the mean. So and this continues on for your downstream analysis, which is whether you want to do like comparison, mean comparison. In this case, because it's skewed, then you will want to use Mann-Whitney U-test. Whereas if you want to do correlation analysis, you want to use Spearman rather than Pearson. So this will decide what test that you will utilize later on. So this is very important. So the first step after you have enter your data, the second step is to clean your data. So you verify your data. Basically, you have to make sure that if you have the primary source, for example, it's a questionnaire, you want to check again whether your data is correct, transferred correctly. Then you want to do this normality test so that you know the nature of your data and then you can decide later on what type of analysis you want to use. I think that's all for today's session. So as usual, if you have any question, if you want me to check for any basic statistic or want to look at your data, so you can do so by emailing to me at this email. Then we can try to set some appointment, I guess. And then we can sit and try to do together. Most of the time, I won't do straight away for you because I'll just guide you and then you can do at your own leisure and at your own pace. So that's all.